Welcome back. Today we're going to talk about a really fun topic. And what's more fun than set theory? Yeah. Set theory is absolutely fantastic. So we should just start off with some basic definitions to make sure, hey, we understand what's going on here. So a set contains objects or elements. A subset is contained in a set and is a set itself. Great. So we have the definition of set, we have a definition of subset. An object or an element is just like, it could be a number, a letter. It's just a thing that exists, simply put. Okay, so now I think the best part would be to learn some notation. So a subset, so if B is a subset of A, this implies this. B is a subset of A. Sometimes it's written this, which means it could potentially also be equal to it. All right, now to say, let's do an example. A is an element of A. How would we write this? So it's denoted by this symbol. Literally means is an element of. That's what that one means. So let's see some examples of sets. So let's go to example 2. Given a set A, B, C, given a set A, B, and given a set C that contains E. So, talking about some notational things, there's one thing in that set, so it's called a singleton. Great. So one thing that we note right away is that A, this set, contains these two elements. So right away we can write B is a subset of A. It's also not equal to it, so we don't need to necessarily put the bar underneath. So, and we know that for a fact. C, the element in C is E. E does not contain in either of those, so E is not a subset of either of those. Great. More notational things about sets. So we have these things called union, which is like the addition of sets, denoted by a union B. So like think about those U's. Great. Intersection, the common elements, denoted A with like the backwards or upside down U. Then we have like subtraction, taking elements out. Ooh, that spelling got a little weird. Okay, that's usually denoted either A minus B or A with a slash in B. Got one more to talk about, complements. The opposite So let's say you have a set A. A complement is denoted as that, or A prime, which is equal to x minus A, which brings up an important point. Well, what the heck is x, right? We don't know. What is this x? Well, x is defined as everything. So essentially the universal set. X is the universal set. So this brings up a good point that we can go off of. What is the complement of x? If x is everything, what is the opposite of x? Yes, nothing. This is called the empty set. Great. Let's go back to our previous example, example 2 then, where we gave A having 3 elements, A, B, C. We had B having just A and B as elements, and C just having E. Great. Okay, let's do some operations on these. Let's do some A union B, A intersect B, A union C. Yeah, I think that's all we're going to do. And I guess, for this sake, we could define X, the whole set, to be A, B, C, D, E. So let's do one more than a C complement. And we should probably do a set subtraction. So A minus B. So let's find out these answers, shall we? A union B. So we're going to take these things and we're going to add all the elements together. So that's just A, because B has all the same elements that A does, with the exception of C. C is something that A just has. So we're going to take the intersection of A and B now. A and B are the common elements, so that's what it has. A intersects C, nothing in common, so it's the empty set. C complement is equal to X minus C, so it's A, B, C, D. A minus B, so we have A, B, and C here, and A and B here, so we're just left with C. And let's actually talk about one more, because this is kind of a confusing thing that people get tripped up on. What about A minus C? You have A, B, C up here, but you have E here. Well, there's no E in A, so you can't take away anything. It's just A, B, C. Great. We could talk about, I guess, one more example of something someone might do with sets. So that's pretty simple as far as it gets. Some people would do like a, hey, here you have this box, let's call it X. There's A and B. Here's C. So if you had something like C complement, it would be everything that's not C. If you had something like A union B, all that stuff. A intersect B, this stuff, right? So you can do Venn diagrams with them as well. Okay, let's get on to example 3. The notation on this one might be a bit harder, so if you have any questions, just comment and I will get right back to you on them. So let's define A to be the set of all things that are x squared is less than 4, where x is a, let's go with integer. So this z here, this big Z, means integer, right? Negative numbers like -1, 0. Yeah, the positives like 1, 2, 3, 4, blah, 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 blah. Great. This right here, if you're not familiar with that notation, that is a such that. So essentially this is saying is the set A such that it contains all the elements that are x squared less than 4 such that x is an integer. So I do actually want to change something so we have a few more things to work with. Let's make that less than or equal to. Great. So we want to find out what are all the elements in this set. So let's put our mind to the test and see what we remember. So let's pull up this. Okay. X squared less than or equal to 4 implies that x squared minus 4 is less than or equal to 0. So we can factor this now and try and find some nice solutions. So this, if you remember your factoring days, factors out into x minus 2 and x plus 2. Y a squared minus b squared is equal to a plus b times a minus b. So now we have this. So what solutions are we looking for? Let's consider the first one. And then the second one. Great, we have both of those solutions. And let's check to see if those solutions look decent. Because there might be an issue. What you have to do sometimes for these solutions is make sure that both of them are valid. So let's check this out. When we solved out this one, totally not going to happen, right? If you plug in a 3 in here, that's not going to work. So that's useless. If you plug in a -2, that's going to work. If you plug in a +2, that's going to work. And anything that sits in between this -2 and 2 is totally going to work, right? Because it's going to be less than 4. So just plugging in those numbers and seeing, hey, what works here, what doesn't. This is an epic fail. That doesn't work. So, now that we know the solutions, and since x was given to be an integer, we can say that, hey, A is the set of 4, not -4. A is the set of -2, -1, 0, 1, and 2. Because it's x squared. If it was just x less than or equal to 4, it would be 4. And in this case, this is what our set looks like. So if there are any questions about what happened in the video, let me know. Like, this is all that we covered today. I think we did pretty great. Thanks for watching.